All right, first derivative test. This is one that we're going to use all year. It's extremely important. It's going to come up time and time again. The first derivative test helps us find relative maximums and minimums. It helps us find relative extrema. All right, at the relative maximum, the derivative, f prime, changes from positive to negative. And at the relative minimum, f prime changes from negative to positive. Now we are going to use, as part of our process, we're going to look for critical numbers. So we're going to look for places where f prime of x equals 0, f prime of x is not defined, and we're going to use those as possible relative maximums and minimums. But these conditions do not create relative maximums and minimums. All right? The derivative equaling 0 and being not undefined does not mean relative extrema. It means a possible relative extrema. So let me show you an example of why that's the case. Here we have a few simple relative minimum here, and you can see that the slope goes from negative to positive, right? It's also true right here that f prime of x equals 0. Right? And likewise here I have a relative maximum. I can see that the slope goes from positive to negative, and it is also true that f prime of x equals 0. Right? I could have another example where this maybe has a sharp turn. Now my slope goes from negative, the derivative goes from negative to positive. So I do have a relative minimum there, and here f prime is not defined. Right? But we could also have a situation like this, where we have a horizontal tangent line here, and yet to the left of that critical number we have a negative derivative, and to the right we also have a negative derivative. F prime did not change from negative to positive or positive to negative, so we do not have a relative extrema there. All right, so that's an example of we have a critical number but not a relative extrema. So it's really important that we think of relative maximums and minimums as a change in sign of f prime. So here's an example. We want to find the relative extrema of this function f of x on the interval from negative infinity to infinity. So the process that we're going to find or use is we're going to find the critical points. So we take the derivative, f prime is 2x plus 8. We set it equal to 0. We solve for x equals negative 4. We also need to think about places where this derivative would not be defined. In this case, there are no places like that. There are no x values which are not defined there. And then we use that x equals negative 4 again to make a chart. Exactly the same kind of chart that we made for looking at when a function was decreasing or increasing in the last example. We have x equals negative 4, we have to the left of negative 4, and we have to the right of negative 4. So I choose a test value. Again, it does not matter where in this interval I choose. I want to use a number that seems like it would be fairly easy to do the calculation on. I find out what f prime of 5 is. So here I did f prime of negative 5. So I have 2 times negative 5 plus 8. I can see that that's going to be negative 2. F prime is negative in this entire interval, so f is decreasing. To the right of x, I do a very similar thing. Here I chose 0 because it made it an easy calculation for me. So I saw that it was positive 8, so f prime is positive, and that means that f is increasing there. So my conclusion then is that f has a relative minimum at the point where x equals x equals negative 4. Since the derivative goes from negative to positive at that point. This justification is very important. On the AP exam, this is what you get credit for. You won't actually get credit for the table. The table is your work. The conclusion is what you get. That's the answer that actually gets graded. So it's important that we make that conclusion very explicitly. So a little bit harder problem. find the relative extrema of this function. It's x squared minus 4, the quantity all raised to the 2/3 power. The process is the same. No matter what the function is, the process is the same. We find the critical numbers. That's when the derivative either equals 0 or is not defined. So taking the derivative is the first step to that, obviously. So as we look at this, we want to think about when this equals 0. This f prime equals 0 when the numerator equals 0, and that would happen when x equals 0. So essentially I say, okay, well, when is 4x going to equal 0? I solve for x. It's going to happen when x equals 0, obviously. And this derivative is not going to be defined when this quantity here is equal to 0. That'll give me a 0 denominator. And that happens at positive and negative 2 because of that x squared minus 4. So I have 3 critical values here, or 3 critical numbers. I have negative 2, 0, and 2. So my table is a little more complicated this time. My intervals are going to look like this. I have my critical values, negative 2, 0, 2, and then the intervals in between those critical values. Again, I'm going to choose a test value somewhere in that interval. I'm going to figure out what the sign of f prime is, and then I'm going to have a conclusion there. So as I work through this table, here I chose x equals negative 3, f prime of negative 3. Again, I plug that in, so f prime of negative 3 is equal to 4 times negative 3 over 3 times negative 3 squared minus 4 raised to the 1/3 power. And here, with these more complicated derivatives, here is where my concern about the sign of this derivative is really what matters. So that kind of keeps me from having to really do a lot of the arithmetic. So I can see this denominator, I have a positive 3. This is going to be 9 minus 4. That's positive. The cube root of 5 is positive. So that denominator is a positive number. 4 times negative 3 is negative 12. That's negative. That means my overall derivative is going to be less than 0. And the conclusion is that f is decreasing on that interval. All right, I have my critical number. I have the next interval. I choose some value inside that interval. Again, I choose one that's relatively easy to calculate. I do the same thing. I want to find f prime of negative 1. I do it the same way I did this. In this case, I find that f prime of negative 1 is greater than 0. So it's a positive number. That means f is increasing. So on for x equals 1 and x equals 3. So by the first derivative test, I can see that at x equals negative 2, my function went from decreasing to increasing. That means that this is a relative minimum. At x equals 2, my function goes from decreasing to increasing. That means this is a relative minimum. So I have relative minimum at x equals negative 2 and x equals 2 because the derivative goes from negative to positive. At x equals 0, I see that f goes from increasing to f decreasing. So I have a relative maximum there. Relative max at the point where x equals 0 because the derivative goes from positive to negative. Right. Showing that table and then also writing out the conclusions is really important to getting full credit on these types of questions. We have to be really familiar with these processes. And so keep in mind, a relative minimum happens when f prime changes from negative to positive. A relative maximum happens when f prime changes from positive to negative. And those are the definitions of relative extrema.